Hello everyone, I'm glad to be here with you today to introduce you to our new rheometer series. I am here in the lab and I'm going to show you how to work and operate the device. Next to me we see our new MCR, which is already equipped with a temperature control unit. However, before we can start testing, we need to set up the device. At first, we need to boot it. As a next step, we can follow the introduction on the HMI interface and we simply click on Start. Next, we need to level the device to have a perfect parallel alignment of our device and to increase repeatability of the results. To do so, we go into the leveling of the HMI interface and I go on the rear side of our instrument to rotate one of the adjusting screws until the indicator of the screen turns green and indicating me that my device is now perfectly leveled. Okay, the device is now ready. So basically we can conclude our configuration. At the moment we already have a lower measurement plate and as already said, we can operate it with a plate-plate or cone plate configuration. So basically we need an upper measurement system. In this case, we will use a cone plate measurement system. All of the measurement systems are equipped with a toolmaster functionality, which means that they are automatically recognized by the device. And we also have a quick connect coupling, which allows us easy and effortless installation of the measurement system. Following again the instructions on the HMI screen, we can see that the next step is the determination of the reference position, which is historical our zero gap position. So basically now we just lower the geometry. Okay, so while we're waiting, we can have a quick look into our sample. For today, we are gonna measure a simple body milk sample in a simple oscillatory test and at a specific temperature. So as soon as we're finished here, we can start to set a temperature for the test. First thing, I turn on the temperature control unit. And secondly, I define a temperature, which will be in this case 25 degrees. I confirm, and here also on the main screen, we can see how the temperature is either increasing or decreasing. As soon as our target temperature is reached, we can start to apply the sample. To do so, I move to the loading position. For an easy application of the sample, we can use the backside mirror as well as the True light. So I will turn it on and I will apply a small amount of sample in the center. Okay. Next thing, we need to lower the geometry onto the measuring position. Again, just a simple click. After we reach here the final position, the next step is the trimming of the excessive material. And here again, I can use the mirror from the backside to improve the visibility. I use a spatula and I simply remove excessive material. So last step for sample preparation is simply the click on continue. And with that, we complete the preparation and we can start to have a look into our RheoCompass software to set up the test. So to start the test, what is missing? Basically only to define the name and we need to click on continue. So to define a name, I start the current test. I name the sample to body lotion and I click on continue. Following the workflow of our template, we can see that we have a first weighting step. In this step, we allow the sample to relax and we allow also the temperature to reach out homogeneously throughout the full sample filling. After this first weighting block is over, the measurement starts. And in this amplitude sweep, we increase the strain rate, keeping the frequency constant. And here we already see our first measurement data corresponding to the loss modulus and the storage modulus. For our body lotion sample, this amplitude sweep gives us information about the structural stability of the sample as well as also the operation performance. Okay, now we see that the test is finished and we can have together a look at the data we generated. As already mentioned, we have a storage modulus and a loss modulus, and the RheoCompass in addition also calculates in automatic the end of the linear viscoelastic area, which we can see here. And it also proposes a suitable shear strain for subsequent frequency sweep tests, what we can see here. Of course, also additional analyses are possible. For this, we just select the raw data. We go here in the interactive analysis menu and we select, let's say in this case, it makes sense to also calculate the crossover point of G prime and G double prime. We automatically calculated the flow point, which is visible here in blue. Thanks to the modularity of our meter, we can not only control temperature, but we can also control other environmental conditions, which is, for example, humidity, pressure, and also UV light. In this example, we see a configuration where we use a Raman setup. Here we use UV light to start a curing reaction in the sample. With the rheometer, we get information about the changes of the material viscoelastic properties, and at the same time, we get the Raman spectrum to get simultaneously information about the chemical changes on a molecular level. Our MCR rheometer series is not just a rheometer, we can also perform a series of different tests. In this example, we see a dynamic mechanical analysis. We are looking here at the MCR 703, which is equipped with a linear drive and a rotational drive. And this allows us to perform a fully equipped DMA measurements under torsion, tension, bending, compression, and even axial torsional mode is possible. With this setup, we can have an in-depth analysis of solids and also viscoelastic solid materials. Usually, the alignment of DMA fixtures can be challenging. Here, the usability features of the rheometer, such as the tool master, the quick connect coupling, and the automatic alignment, allows us to do this in a simple and easy way. We just need to click on the reference position, and you can see we have an automatic alignment. Okay, now our setup is ready to start testing. As a final setup, I would also like to show you our powder rheology configuration. Basically, in powder rheology, we focus on the characterization of powder flow as well as also on the simulation of real-life conditions. Unlike other materials, powders are very difficult to predict in terms of their flowability, as we have many influencing factors coming from particle size and shape, but also from the environment, which can be humidity, consolidation state, and also fluidized conditions. All of this makes powder testing essential to optimize the handling of the powder, to optimize formulations, and also processing and storage conditions. We have here a look at our MCR, which allows optimum visibility of our fluidization setup. It is a powder flow cell equipped with a dust protection hood to perform fluidization in a safe manner. So basically, we can close the measurement cell. Now we see that the measurement cell is completely sealed and we can start to turn on an airstream. Thank you for watching. I hope you enjoyed the demonstration of today and you got a small insight in our MCR rheometer portfolio. If you need any more information, please have a look at our website or contact one of our sales representatives.